Hi everyone. In this video, we're going to talk about actually writing linear equations. We've done all the practice with y equals mx plus b, which is slope-intercept. We've done slope formula, finding the rise over run. We've done horizontal, vertical lines. We've used a table. We've used graphs. We used coordinates. Now let's actually write the equation. So if I were to give you a graph and I've done all of the work for you, I want you to tell me what is the equation that will match this graph. How do you think we could figure out an equation? Well, let's talk about our friend, the slope-intercept form. What is slope-intercept form? That's our go-to way of graphing, and it's the equation y equals mx plus b. If you have some of this information, then you can write an equation from a graph. Looking at this graph, what do you know? Do you know the b? The y-intercept is down here. What is that value? -1. We're going to start it with our y equals. So now we just need our slope. What is the slope? The rise over the run. Let's count. Rise 2. Run 1, 2 over 1. What if I didn't do 2 over 1? What if I did 1, 2, 3, 4, run 1, 2? What if I did 4 over 2? Does it matter? No. What if I did 1, 2, 3, 4, 5, 6 over 1, 2, 3? What do you know about 6/3, 4/2, 2 over 1? They're all equivalent. It doesn't matter. If I write 6/3 and Miss Eaton writes 2 over 1, it's the same thing. All of these fractions are equivalent to the whole number 2, right? We always want to simplify if possible, but no matter which way you write it, it's still correct because they're equivalent. So I'm going to write 2 over 1x. This is the equation to this line. Now, another way is we don't usually put 1 in the denominator, so if you wrote it like this, even better. If Miss Eaton writes 6/3 x minus 1, we also know that that is correct too. She should simplify, but it's not wrong. Let's try another. What is the graph, or what is the linear equation from this graph? So our go-to is y equals mx plus b, slope-intercept form. Get it? Slope-intercept. So we need to know two things. I need to know my slope and my intercept. My b is here. What is that point? Again, that's the origin, 0, 0. So what should I put for my plus b? You want to write plus 0? Sure. Let's put it just for now. Now, what is my slope? Well, looking at the line, is it positive, negative, 0, undefined? It's negative. So my fraction better be negative. Let's find the rise over run. Rise going down, negative. 1, 2, 1, 2, 3. 2/3. Let's check it. 1, 2, 1, 2, 3. Negative 2/3 still. But let's say Miss Eaton is out there, and Miss Eaton is going 1, 2, 3, 4, -4, 1, 2, 3, 4, 5, 6. She gets -4/6. I get -2/3. What's the difference? Nothing. They're equivalent. Okay? You should use the simplified version. Doesn't matter. You'll still get the same answer. It's the same slope. So we're going to write y is equal to -2/3 x plus 0. But, ladies and gentlemen, we know that we don't write plus 0. So we're going to just write this. You should know that it does start at the origin, but we don't need to write plus 0. It's just unnecessary. Can you write the linear equation from this graph? Positive, negative, 0, undefined. This is a horizontal line, which means it's a Hoy line. See how that works? Hoy bucks. This is a horizontal line, which means it has 0 slope, and that means the equation is y is equal to a number. There's no x. So if y has to equal a number, let's look at the y value. That is 0, 2. This point is 1, 2, 3, 4, 2. And this point is -3, 2. So the equation for this horizontal line, is y is equal to 2. No x. It's a horizontal line, 0 slope. All of the y values are 2. Can you write the linear equation from this graph? OMG, there are 3 lines on one. Have no fear. Let's start with the green down here. Okay, remember, y equals mx plus b. Slope-intercept form is our go-to. My y-intercept down here is -2. And what's my slope? What's my rise over run? Well, let's find another good point to use. How about this one? Up 2, run 1, 2, 3, 4. 2/4, which we simplify to 1/2. Let's check it. Up 1, right 2. Boom. Either one works. So my green line is y equals 1/2 x minus 2. Let's do the red line. My y-intercept is up here at 1. What's my slope? Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. So my red line is y equals 1/2 x plus 1. B line starts up here at 4. B line, blue line, starts at 4. And what's my slope? Rise 1, 2, 1, 2, 3, 4. Okay, or rise 1, 1, 2. So my slope, again, is 1/2. So the equation of the blue line would be y equals 1/2 x plus 4. What do you notice about all 3 equations? What's the same? What's different? Look at this. The slopes are all the same. These have the same slope. The y-intercepts are what's different. They all start at different spots, but they are the same slope. Take a look at red, blue, and green. Do you know what kind of lines these are? That's right. They are parallel lines. Okay? Fun fact you need to know, parallel lines have the same slope. They are equidistant from each other. They are the same steepness. Parallel lines have the same slope. Write it down. Say it out loud. Parallel lines have the same slope. Parallel lines have the same slope. Last example, let's do a word problem. The graph shows a trip taken by a car where t is the time in hours and y is the distance in miles from Phoenix. Okay. Before I continue on with the questions, it's really important to, anytime you get a graph with a word problem, take a look at the graph. What do you notice? What does the x-axis represent? What does the y-axis represent? How am I counting boxes? I'm no longer counting by ones. What about my y-axis? This is definitely not counting by ones. All of these things are really important to talk or to think about when you have a word problem or a graph where my axes are labeled different. Word to the wise, most graph word problems are asking for the slope. Let's check it out. So I'm comparing the distance to the time. Question A says, find the y-intercept of the graph. Y-intercept would be here at 100. So I'm going to say my B is equal to 100. 100 what? Miles. And it says, what does that represent? What does the y-intercept represent here? We're talking distance, and we're starting at 100 miles. Remember, your y-intercept is your starting point. So this means we start at 100 miles. Okay? We're talking the distance from Phoenix. So we are starting in our car 100 miles away from Phoenix. Question B, find the slope of the graph. Okay, let's figure out my rise over run. Rise 2 boxes. I'm rising 2 boxes, but is it 2? No, I'm rising from 100 to 200. So how much is that really increasing? My M would be I'm rising 100 and I'm running 2 boxes, and that does represent 2. So my rise is I'm rising 100 miles over 2 hours. Let's simplify that. What's 100 divided by 2? I'm going 50 miles per 1 hour. Miles per hour. That's my slope, and that's what it represents. That's how fast I'm driving. 50 miles per hour. That's how we write it in the car. Take a look at your speedometer next time you get in your mom or dad's car. Our rate of change, remember that word, rate of change, the rate that we're driving to or from Phoenix is 50 miles per hour. How long did the trip last? Well, remember my x-axis is time. I start at 0 and I end at 6. So how long did it last? It lasted 6 what? Hours. How far from Phoenix was the car at the end of the trip? How far from Phoenix? So I am at 400 miles, right? This is the end. And I'm at 400 miles. So is my answer 400 miles? Where did I start? I started at 100 miles away. So how far away was the trip? I started at 100, I end at 400. It was 300 miles, right? What's 400? My ending minus my starting. Last one, write an equation that represents the graph. So we're going to put everything together. We're going to use y equals mx plus b, my slope-intercept form. My starting point is 100 miles, and my slope was 50 miles per hour, my rate of change. So word problems with graphs, they'll definitely always be looking for the slope. They'll kind of really love a good equation to match the graph, and y-intercept, your starting point, is definitely important to help you write those equations. Let's go check out more word problems on our own.